Today I want to take a look at the PowerShell command format table. The alias for this one is FT, so commonly you'll see it in PowerShell scripts as vertical pipe FT-A because the auto size parameter is so popular, and format table is a short form alias with FT. So this displays output on the command line as a table, selected properties, and you can use the property parameter to select the individual properties you want. Sometimes that comes up. Other times you'll see pipe with select, prop 1, prop 2, and then FTA. But this finishing of pipe FTA, we see that finishing of single line commands a lot, but wanted to explore the command overall for some of the other things that it's capable of doing. It has different default formatters. This is kind of interesting where we get into the types of data coming in. If it's a collection, an array, a hash table, maybe XML. And you can also add calculated properties by working with a hash table before and then specify those column headings. So we'll start with the basic one, example 1, formatting the PowerShell host with auto size. Coming over to ISE, I do have the 8 examples already imported. And for this one, we'll go ahead and clear out our console. On the left, we'll execute get host format table auto size. And you can see there's 3 properties coming in, the name, the version, and instant ID. Now, with all of this, the auto size makes the spacing such that it widens the columns and we can see all values coming back. If we execute the command without format table, you can see the default listing is a vertical layout. If we execute format table without the auto size, in this case it works, but sometimes you'll see things kind of run off and it'll just say ... and it'll hide some of the data and truncate. So the truncation is what we're trying to avoid when we bring in auto size. That's the first example. For our next example, we have the format table with a group by and a wrap parameter. So we're going to group by base priority, and then we're also going to wrap. And that ensures that the data is not truncated. So if we come over to PowerShell ISE, we can go ahead and execute example 2, and we'll see the group by with the wrapping. We'll bring this part over here and execute that. So you can see the base priority now coming in at different headers. So this is what group by is giving us, that yes, we do have the table, but we're actually ending up with multiple tables, each one in a different grouped heading. And -wrap ensures that there's no data truncated. So you can see some of these names are kind of lengthy and it ends up with a blank line. And this is what wrap is going to give us, where it will wrap the text to a new line. If we execute without the -wrap, so we'll learn about it by running varieties. And this is, by the way, one of the things I like about working with ISE, kind of an interactive console. Well, a few things, a bit of a tangent, but we can go ahead and execute by highlighting code and pressing F8 to run only the highlight. So if I highlight everything without the word wrap, then that gives us the ability to run the command again. And here we'll see, there it is, ... And here you can see the 3 dots ending a given line. There is no blank space, and that is truncated text. That's what we're avoiding when we add -wrap. So kind of showing it with and without for example 2. Now moving into example 3, format processes by start date. This displays information about the processes run on the computer, uses a view to group the objects by their start date. So we'll go ahead and run that one. It's a sort and then -view start time. So let's go ahead and clear this out. We'll execute example 3, highlight the line and press F8. There we go. View start time. Yes. So here we're actually leveraging one of the formatters that's defined in the .NET types format PS1XML, and the name of that view is start time. So this is a special configuration for process objects. Doesn't apply to everything, but essentially we're leveraging a shared view that's defined in the background, saying, well, we want to view it by start time. Well, what does that mean? What is start time? When given process objects, it will convert it to a short date string we can see here, and then handle the group by. So this is essentially a short date and a group by. Those together are named view start time, and this is defined as part of your system configuration. Now, why is that helpful? You can make your own views. You can define views with other criteria that you would like. Your favorite view, whatever sort of grouping, sorting, maybe other formatting you'd like, and save that view in the background so that you don't have to maybe apply all the sort and group and type it out every single time. Think of it a bit like a SQL query. You're taking a SQL query, saving as a view, and now you can format the input data with that view over and over again. Our next example is going to be get child item with a myGCI view. So this one, example 4, uses a custom view for table output. Yes, and this view adds the creation time column to directory info and file info. And the name of the view is myGCI view. Again, this is another formatter that comes with PowerShell and something that we can leverage, but also extend and add our own definition. Now for the system I'm working on today, we'll change that to temp, highlight the line, execute F8. And when the view executes, it's saying that view was not found, myGCI view. And that makes sense because that's a custom name that doesn't come with the system. Going over to the articles, there is a click through to learn more about format PS1 XML. And this takes us into an article about how to set up your own views. There's a couple of different things to it. These are going to be commands that include the word format data. So you can create your own format PS1 XML to change the display of objects in PowerShell. Coming through this, there's table, list, wide, custom, what type of layout. Usually we're going to be working with table. How do you create one? What would that look like? And they go through a couple of different samples. And if we search for my GCI view, here we can see in the following command, there's an alternative to ensure local formatting is provided. So get format data for directory info, export it to my GCI view, and then update the format. And down here you can see how these are saved on the file system, that the XML is essentially taking in what type of object, of course the name of the view, and then here is a group by expression, and here are different table headers. You can even specify alignment, left, alignment, right, a width potentially. Very interesting stuff. You can get really precise with how you want the format table command to render. And if you want things to wrap, what the column items are going to be as far as naming, and that brings in some sample headings. So last write time, creation time, length, and name. But this is what a custom view looks like when it's saved into the file system. So if you have that defined, you can create ones that you'd like to use, and then simply use -view as a way of providing all of this formatting criteria at once. So if you have a particular render of format table you're always using, I'm always doing these selects and sorts and group bys, and you're always kind of adding that extra pipeline to your format table, maybe you want to take that, save it up as XML, and reference it with a view. Next, example 5, you can use properties for table output. So here we're selecting 2 properties. We'll go over to run execute example 5, bring that into a fresh console, highlight the line and press F8. So there are our property names that we're looking at bringing in, name and dependent services for Windows services that we have. So again, like if we change it, and that's one of the beautiful things about working with ISE, you execute what's highlighted with F8. So giving the property names, we have 2 columns. If we go without that, we have 3 and things are truncated. And you can see all the truncated text and the run state, stop started. Maybe we don't even care about that. So we change it to different properties we want to have visible. That is example 5. Moving down to example 6, format a process and calculate runtime. So this is one of my favorites because of the formatted calculated column. That yes, we're formatting this table, but we're adding a column called total runtime, and we're giving it an expression that goes right here between the curly braces. And that expression is what's going to do calculation. Super cool stuff. So if we come over and we execute this in total, get process, And we'll pick a process that we know is running. There we go. We have a couple of Chrome processes. Excellent. Now, if we were to run that without the custom column, running it in the short form, we just get the process name. Or if we simply say format table, we get the default fields. So you can always work with this a little bit as far as, what's the default without telling it format table, add a little more, add a little bit more, and then add the whole thing. It's pretty interesting. It's cool stuff. And the expression here is taking the current time and subtracting the start time. So how long has this been running? 4 minutes, 17 minutes, that kind of thing. And the total runtime is the header of the column. So you can see that as our custom column, total runtime. That's called the label. And then, of course, the expression is how we calculate the data, and that comes through here. It's going to be a time span object in this particular example. And it lets us create our own fields dynamically. Really good stuff. This is helpful in a lot of different use cases. The thing about this one to remember is just the general formatting, that we have label, we have expression, and a semicolon in between. So as you're typing these out and kind of practicing them, there is a curly brace for the entire formatted custom column, but then there's an extra one for the expression over here. So just kind of keep an eye on the nesting, that we do have the outer brace for the custom column and then an inner brace for the expression. Label name is a string, so you're going to have a double quotes over there. Cool. Let's go take a look at our next example 7, format the Notepad process. So here we're running through a similar sort of thing. This would use remote computers, get sim class, filter, process name, label, and let's change this up a little bit. We'll clear out our console and we'll use the get sim class. F8. So same sort of thing. This is using a different method of collecting the data. It's coming from get sim instance, our WMI provider, Win32 process. So we're collecting it, but we're not using the get process command. We're using a different method to collect data. Finally, for example 8, troubleshooting format errors. The results of adding the display error or show error without an expression. So on this one, we're adding the dash display error as a way of learning more about the formatting's attempts. So it has, pound ERR for this custom column that's just not actually able to calculate. Now, if we want to change that, and from display error, we change it to show error, highlight and execute. Now we get a lot more detail. So display error was telling pound ERR on the output. Show error is saying failed to evaluate $_ divided by null, invalid argument, expression error. So this is giving us a lot more visibility into the calculation not working. So as you're trying label and expression for calculated columns, you may want to add show error as a way of learning more about what it's not able to format. Divide by 0, missing input. These sort of things are going to happen. You may have a record set 10, 20, 30 rows. Most of them do okay, but one of them doesn't. Adding show error will give you that tracing visibility to narrow things down. So that's our demo today for format table.